Hello, we're going to look at understanding transformations. Consider the point f of x equals 4 comma minus 3. This means that the function maps x to f of x. So if the input x equals 4, then the output y equals minus 3 in this case. Let's use this particular point to study how it changes with different notations. Let's start with the original function y equals f of x. There is no effect on y or x, and there is no transformation, so the image is the same 4 comma minus 3. However, if you change the sign on f of x, it simply means the sign on y reverses, but the sign on x remains the same. Now let's check this with an actual function. Let's plot the graph of y equals x squared, and then let's plot the graph of y equals minus x squared. You can see that this graph has been flipped across the x-axis. And this is because every value of y on the red curve becomes negative for the same values of x. And so we can say that this transformation is a reflection in the x-axis. And the new image is 4, comma 3, where the sign on y has been reversed. If y equals f of minus x, this means the sign on x reverses, as is obvious here. But the sign on y remains the same. How do we know that? Because on the outside of the function there is no change of sign. Let's look at an actual function to see this happen. This time, let's plot the graph of y equals x cubed, which is this black curve, and the graph of y equals minus x cubed, this red curve. So if you can see what's happening here, to check, we'll just draw another line called y equals 1. So this basically maps all the points on the y equals 1 line. And you can see the points here on the curves. You can see that the x value has flipped sign, whereas the y value remains the same. So this function has been flipped across the y-axis, and therefore the transformation is reflection in the y-axis, and the image is one where the x value changes sign but not the y value. What about y equals f of x minus 5? To see this, let's actually plot this particular function. So we'll choose our original function y equals x squared, and then y equals x minus 5 the whole squared. If we use this guideline, the y equals 1, and then check points on these two curves at corresponding positions, you can see that the x value has increased by 5 in the case of y equals x minus 5 the whole squared. So what does this mean? This means that you translate right by 5 units. That is the transformation. And the image has the value of x 5 more than its original value and the value of y the same. Now let's consider y equals f of x minus 3. As you may realize, this is simply adding negative 3 to the output y, whereas x remains the same, as you can see here. Let's look at how this looks on a function. So if you have y equals x squared, and then you have y equals x squared minus 3, then you can see that, for example, the vertex 0, 0 has simply become a new vertex 0, comma minus 3. The shape of the curve doesn't actually change, it just moves down by 3. And so this particular transformation is a translation downwards by 3 units, where the y value becomes 3 less than its original value. If you have y equals 2 times f of x, that means the values of y are multiplied by 2. How does this look when we plot it on a function? So if you take y equals x squared and then take y equals 2x squared, then you can see that the curves look like this, where the purple curve is the new function. Well, how is the new function changing? Let's use the x equals 1 line to check this. In other words, we're going to see how y changes along a constant value of x equals 1. So on the first curve, if you choose the 1 1 point and the corresponding point on the second curve 1 2, you can see that y has doubled as expected from the function 2x squared. The 2 is the doubling factor. So this curve is vertically stretched, and the transformation is called a vertical stretch by factor 2. You can see that the image is the x value with the y value multiplied by 2. If y equals f of x divided by 2, then let's look at how the function is represented. So you have x divided by 2 whole squared, and let's use a guide y equals 1 to see how the x values are changing. So the original curve and the new curve have got different values of x for the same value of y. You can see that the value of x has doubled in the case of the new curve. So this is called a horizontal stretch by factor 2. So note that even though the function shows x divided by 2, what it means is that x is actually doubling, with respect to the original function. And so this can be called a horizontal stretch by factor 2. So x is doubled and y remains the same. Finally, y equals f of 2x. Let's see how this looks on the graph. So you have the original function, and then you have y equals 2x squared, and let's take off the x by 2 whole squared. So you see the new function also appears to be appears to be narrowed. This function, let's let's check and see how its values are changing. So this function will be half of the original value. We can do this by drawing the y equals 1 line. And if you check the original function 1 1, then you have 0.5 comma 1. So you see the value of x has divided by 2. This is called a horizontal stretch by factor half, because the value of x becomes half the original value. So note that even though it's 2x whole squared, what's really happening is that x is becoming halved each time. And then this particular transformation can be called a horizontal stretch by factor half. And the new image is the x value divided by 2 and the y value remaining the same.